Hello everyone, welcome to this tutorial series of computer networks. Till now we have discussed many multiple access protocols such as random access protocol and channelization protocol. In the random access protocol, we have discussed Aloha and different CSMA methods such as CSMA CD and CSMA CA. In the channelization protocol, we have discussed FDMA, TDMA and the CDMA. The last method for the multiple access protocol is called controlled access protocol. So let's see. In the controlled access protocol, a station cannot send unless it has been authorized by other stations. So a station seeks permission from another station to send any data. And this method helps to avoid collision of message on a shared medium. There are three types of controlled access method: reservation method, polling method, and the last one is token passing. Let's discuss all these methods one by one. The reservation access method. In the reservation access method, the total time is divided into two parts. The first is called reservation period and the second is called data transmission period. Now what is reservation period? So if a station has any data to send, then it must make a reservation during this period, which is called reservation period. And what is data transmission period? So station can send data in this duration only if it has made reservation during the reservation period. So suppose length of the reservation period is 10 seconds and there are 5 devices in a network. So the reservation period is divided into n slot where n is number of devices. So we are in our example there are 5 devices, so the reservation period is divided into 5 slots. So each device will have their respective reservation slot. And if any device wants to send any data, they must make reservation in the respective slot only. Now you can clearly see that length of each slot is 2 seconds. So suppose device 1 wants to send data. So to send data, device 1 must make a reservation in its respective slot only. But the question is how to make a reservation. So to make a reservation, device has to send 1 in the respective slot. So if device 1 is sending 1 in its respective slot, all the remaining device will understand that this device wants to send data. If device 2 wants to send any data, device 2 will make reservation by sending 1 in its respective slot only. So when remaining device will receive 1 during this slot, these all devices will understand that device 2 is going to send data. Suppose device 3 don't want to send any data, so it will send 0 in its respective slot. So all the remaining device will understand that device 3 is not going to send anything. Suppose device 4 is also doesn't want to send anything, so it will send 0 to its respective slot, right? And suppose device 5 wants to send any data, so it will send 1 in its respective slot, so the remaining device will interpret that device 5 is going to send data. After the reservation period, the period which comes is called data transmission period. And in the data transmission period, devices can send data only if they have made reservation in the reservation period. So as you can see here, device 1, 2 and 5 have made the reservation, so this device can send only data during data transmission period. So the first data which is sent is by device 1. After the device 1, the device 2 can send data, and after the device 2, the device 5 will send data, right? So in the data transmission period, the devices that have made reservation, only those devices can send data. Now let's try to understand with another example. Suppose there are 5 devices and the reservation period is divided into 5 slots. So device 1 is sending 1, it means that device 1 has data to send. Device 2 doesn't want to send any data, so it will send 0 to its respective slot. Device 3 wants to send data, so it will send 1 to its respective slot. So when remaining devices will receive 1 in this slot, those devices will understand that device 3 is going to send any data. Suppose device 4 wants to send data, so it will send 1, and device 5 wants to send no data, so it will send 0. So this duration is called reservation period. So in the reservation period, devices that wants to send data have made reservation by sending 1, and device that doesn't want to send any data have sent 0, right? And after the reservation period, the period comes that is called the data transmission period. So in the data transmission period, you can clearly understand that the first data which is being sent is by device 1. So device 1 will send data. After device 1, device 2 hasn't made reservation, so it will not send data. Device 3 will send data and device 4 will send data. So you can see that all the devices that have made reservation in the reservation period, they send data during the data transmission period, and after the data transmission period is completed, again the next period is called reservation period. Now suppose device 1 wants to send data again, so it will make reservation by sending 1. Device 2 will send 0, it means it doesn't want to send any data. Device 3 0, device 4 is also not making any, right? So after this reservation period is completed, the next period is data transmission period, and you know that in this data transmission period there will be only one data which is being sent by the station 1, and after all the stations that have made the reservation have sent data, then again the next period is reservation period. Okay, the second method is polling method. In the polling method, all the devices that are connected in the network are divided into two categories. The first is called primary stations and the second is called secondary stations. All the data exchanges are made through the primary stations, and the message sent by primary station contains the address of secondary station. And if any primary station wants to receive data from secondary station, the primary station will ask the secondary station if they have any data to send. If secondary station has any data to send, they will reply with the data. And if secondary station has no data, then they will reply with the negative acknowledgement. Suppose device A is primary device and device B, C, D and E is secondary device are secondary devices. Device A wants to receive data from device B, then it will ask the device B if it has any data to send. And if device B has any data, it will reply device A with data. Suppose device D is asking device D, then D will reply with data, right? Now, device A is asking device C for data, and suppose device C has no data, so the device C will reply with negative acknowledgement. So the device A will understand that device C has no data to send. You can compare this situation with your classroom. Suppose your teacher is asking questions to all the students one by one, and if any student has answer, so they will reply with answer, and if any student has no answer, then they will say no to the teacher, which means negative acknowledgement. And you can imagine what happens after they have denied to the answer. Let's not get into detail for that, and discuss the next method, which is called token passing. In the token passing method, all the devices are connected in this manner, which is called ring. Suppose there are 4 devices which are connected to each other are A, B, C and D. A token is a special bit pattern which circulates from one station to the next station. So it can be any pattern. Suppose the pattern for the token is 1011. So when any device receives such pattern, they will understand that they have received a token. If a station has frame queued for transmission, when it receives the token, it can send the frame before it passes the token to the next station. So suppose in this example, the device C has data to send, but it will not send data directly. It has to wait for the token to arrive. And when the token is arrived to device C, then and then it can send its data. Right now the token is at device A, so device C cannot send data. The token will be passed to D, but D has nothing to send, so device D will pass that token to the device C. Now the device C has data to send and the token has arrived, so device C will send data. The flow of the data can be both clockwise and anti-clockwise, right? But this method has a disadvantage. Like, what happens if the value of the token is changed? Suppose that the value of the token we have taken is 1011. Now what happens if the single bit is changed due to the noise in the medium? Now if this bit is changed, no device will understand that this is token, because the value of the token was 1011, but due to noise it is changed to 1010. So even any device receives this token, they will keep waiting for the token and they will wait for infinite time and no communication will occur. So that can be considered as a big disadvantage. There are different type of token rings such as physical ring, dual ring, bus ring, and star ring. In the physical ring, all the devices are connected to each other in this manner. 1 is connected to 2, 2 is connected to 3, 3 is 4, and 4 to 1. In the dual ring, there are 2 rings. So what is the advantage of dual ring? Like if any link is broken, the communication is not stopped. In the physical ring, if link is broken, no device can communicate because the ring is broken. In the dual ring, you can still communicate if one ring is broken. In the bus ring, the topology seems like ring, but it is not ring. This is bus topology. But all the communication will be happen using token. What I'm trying to say is device A can send data only if it has token. If device 1 has token, it will send data and this token will be passed to device 2. When device 2 will receive token, it will send data and this token will be passed to device 3. And when device 3 receives token, it will send data and after sending data, the token will be passed to device 4. Right? So all the communication are happening one by one and using token. That is why it is called bus ring. The last one is called star ring. All the devices are connected using the hub, but all the process will happen using the token only. So this is it for this session. If you have any doubt, you can ask me in the comment section. Thank you so much.